So we are going to see the third theory of chemical bonding, that is valence bond theory. The first theory was Coastal-Levy's approach. Second is valence shell electron pair repulsion theory or VSEPR theory, under which we saw the shapes of molecules. Now comes the third theory of chemical bonding, that is valence bond theory. Now this theory is based on a concept called orbital overlap concept. So let's see what is orbital overlap concept. Orbital overlap concept. Now, according to this concept, a covalent bond is formed between two atoms when a half-filled valence orbital of one atom overlap with half-filled valence orbital of other. Also, the two electrons which are involved in bond formation should have their spin in opposite direction. So there are two things that is to be noted under orbital overlap concept. The first thing is that the half-filled valence orbital will overlap. Half-filled valence orbital of the atom overlap. And the second thing to be noted is that the electrons should have spin in opposite direction. So these are the two important points that comes under orbital overlap concept. So according to this concept, a covalent bond is formed when half-filled valence orbital of one atom overlap with half-filled valence orbital of other atom. And the electrons involved in bond formation should have their spin in opposite direction. Let's see an example for this concept. First, let's see the example of hydrogen molecule. Formation of H2 molecule. Now, hydrogen molecule means we have two hydrogen atoms, and you know the electronic configuration of hydrogen is 1s1. So if you draw the orbital diagram, this is the orbital diagram for hydrogens. For second hydrogen, we can show the electron spin in opposite direction because we know this is half filled, 1s orbital is half filled. So they can overlap, these are the valence orbital which overlap, and this will give rise to H2 molecule whose configuration will be 1s2. Okay, now the next example is formation of fluorine molecule. Formation of F2, fluorine. Fluorine, we have two fluorine atoms and the atomic number of fluorine is 9. So the electronic configuration is 1s2, 2s2, 2p5. Now this fluorine also 1s2, 2s2, 2p5. Now when you draw the orbital diagram, 1s, 2s, 2p, and always name the orbitals. Now 1s2, 2s2, 2p5, 1, 2, 3, 4, 5. You know, according to Hund's rule, pairing takes place after each orbital is singly occupied. Now, for the second fluorine, 1s2, 2s2. Now, you can see that in the fluorine atom, we have one half-filled p orbital. So, this fluorine, when you show the electron, that half-filled electron, you have to show with opposite spin. Now, the fourth electron and fifth electron. Now, these two orbitals will overlap and you get F2 molecule with a single bond between two fluorine atoms because there is only one half-filled orbital of each fluorine overlapping. So we have a single bond between two fluorine atoms. Now next example, let's see for oxygen molecule, formation of O2 molecule. The oxygen, we have atomic number 8 and the electronic configuration is 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. Now when you draw the orbital diagram, 1s, 2s, this is 1s, 2s, 2p, which is for the second oxygen. Now 1s2, 2s2, 1, 2, 3, 4. 1s2, 2s2. Now you can see there are two half-filled 2p orbitals. So when you draw the electron in the second oxygen, we have to show the electron in opposite spin. So here we have 1, 2, 3 and 4. Now these two orbitals, because there are two half-filled orbitals, will overlap and we get O2 molecule. And how many bonds between oxygen? 2 bonds between oxygen, because there are two half-filled p orbitals overlapping. Now the next example is example number 4. That is nitrogen molecule, formation of N2 molecule. Now nitrogen molecule, we have two nitrogen atoms and you know the atomic number is 7. So the configuration is 1s2, 2s2, 2p3. Now when you draw the orbital diagram, 1s, 2s, 2p, 1s, 2s, 2p. Now 1s2, 2s2, 2p3, 1s2, 2s2. Now you can see there are three 2p orbitals half filled. So when you draw the electrons of the second nitrogen, you show with opposite spin. Now show the overlapping, and you can see nitrogen molecule exists as N triple bond N, because there are three half filled orbitals overlapping. Okay, so this is orbital overlap concept. Now next, let us see the types of overlapping. Types of overlapping. Now, under types of overlapping, we can say that the covalent bonds can be classified into two types on the basis of the type of overlapping they undergo. The first type of covalent bond is called sigma bond. So, under types of overlapping, there are two types of covalent bond. The first type is sigma, and sigma is denoted like this, sigma bond, or this is also called axial bond. Sigma bond or axial bond. So, what do you mean by a sigma bond or axial bond? Sigma bond, or how is a sigma bond or a sigma covalent bond formed? A sigma bond is formed by end-to-end overlap of bonding orbitals along the internuclear axis, and this is formed by any one of the following types of combination. So how is a sigma bond formed? By end-to-end overlap of bonding orbitals along the internuclear axis. Now, the sigma bond is formed by different types of overlapping. So, let's see what are the different types of overlapping possible for the formation of sigma bond. The first type is called, the first type is SS overlapping. Now, when you hear the word SS overlapping, it means S orbital, half filled S orbital of one atom overlap with half filled S orbital of another atom. We get SS overlapping, or we get a sigma bond. Okay, for example, so SS overlapping means overlap of two half-filled S orbitals along the internuclear axis, because we know sigma bond is formed along the internuclear axis. So, example H2 molecule, you can see hydrogen, you know that half-filled orbital is 1s. So, we have S orbital which is spherical in shape, 1s orbital of one hydrogen, plus this is the 1s orbital of second hydrogen. And how will you show the SS overlapping? Like this. So this is SS overlapping, or we can say sigma bond is formed by SS overlapping. Now, next type of overlapping is, the second type is sp overlapping. Now, here overlapping between half-filled s orbital of one atom and half-filled p orbital of another atom along the internuclear axis will give rise to sp overlapping. Now, example for sp overlapping is hydrogen fluoride molecule, HF. Now, you know, in hydrogen we have the s orbital, 1s orbital, which is half filled, and fluorine, you know, electronic configuration is 1s2, 2s2, 2p, 5. So 2p orbital is half filled, 1 2p orbital is half filled, and you know the shape of 2p orbital is dumbbell shape, so we will draw like this. We will show only that half filled 2p orbital. Now this will give rise to sp overlapping like this. Okay, so this is sp overlapping, or we get a sigma bond between hydrogen and fluorine as a result of sp overlapping. Now the next type of overlapping is, third type is pp overlapping. pp overlapping, and example for pp overlapping is O2 molecule. Now, you know, oxygen we have two half-filled p orbitals. So, what do you mean by pp overlapping? Overlapping of two half-filled p orbitals along the internuclear axis. Now, here you can show one p orbital, half-filled p orbital of oxygen plus the half-filled p orbital you get, or you can take fluorine also, p orbitals are involved. How will you show the pp overlapping? Yeah, this is pp overlapping, in which a sigma covalent bond is formed. So, these are the three possible combinations of overlapping where a sigma covalent bond is formed. Which are the three combinations or overlapping? First is SS overlapping, SP overlapping, or PP overlapping. As a result of these overlapping, we get sigma covalent bond. Now, the second type of covalent bond is called pi bond. So, the second type, B, is pi bond, and it is denoted as pi bond. Okay. Now, how is it formed? Pi bond is formed when half-filled p orbital overlapping takes place perpendicular to the internuclear axis, which means we have only p orbitals involved in pi bond formation, whereas in sigma bond formation we have s and p orbitals involved, whereas in pi bond formation we have only p orbitals involved. P and D also can involve, p orbitals involved, but in 11th you have only to study about the p orbitals involving in pi bond formation. Okay. Now, how is it formed? Formed by when half-filled p orbitals overlap perpendicular to the internuclear axis. Here overlapping takes place perpendicular to internuclear axis, whereas sigma bond was along the internuclear axis. Overlapping was along the internuclear axis, here perpendicular to the internuclear axis. Now, this type of overlapping is also called sidewise overlapping, whereas sigma bond was called axial overlapping. Okay. Now, I am going to show that pi bond formation. We have one p orbital, this is perpendicular to the internuclear axis, plus another p orbital, and sidewise they overlap, and we get like this. This is the pi bond formation. Or this can also represented by an electron cloud like this. Electron cloud above and below the plane of participating atoms. So, this is also a pi bond. This also represents a pi bond. Okay. So, pi bond is usually formed by p orbitals. Now, next we are going to see the strength of sigma and pi bond. So we are going to discuss which bond is more strong. Strength of sigma and pi bond. Sigma and pi bond. Now, sigma bond is stronger than pi bond. Now, why? This is a very important question. Which bond is stronger, sigma or pi, and why? I said sigma bond is stronger than pi bond. And the reason is, we can say that the strength of a bond depends upon the extent of overlapping. In case of sigma bond, we know that the overlapping of orbitals takes place to a larger extent because it is along the internuclear axis. Whereas in pi bond, the overlapping is less between the orbitals. So sigma bond is stronger than pi bond. And another reason is that the pi bond is always formed in addition to a sigma bond. So whenever you take a molecule, we have always sigma bond present, and pi bond is formed in addition to sigma bond, which means pi bond we observe mainly in multiple bonds or molecules which contain multiple bonds. Multiple bond means molecules which contain double or triple bonds. So if we have a molecule with only single bonds, that will be a sigma bond. If we have a molecule with a double bond, one bond will be sigma, one will be pi. If we have a triple bond, one will be sigma, the other two will be pi. For example, if you know methane, CH4, organic compound, the simplest organic compound butane, we have only single bonds, they are all sigma bonds. Now, ethene, C double bond CH2, CH2, ethene, we have a double bond here, so one bond will be sigma and the other will be pi. Whereas CH bonds, they are all single bond, which means they are all sigma. And ethyne, ethyne is C triple bond C, HH. Now we have a triple bond here, out of which one is sigma and the other two bonds are pi, whereas the CH bonds are sigma. Okay, so these are the two reasons for the greater strength of sigma bond. First is extent of overlapping is more in sigma bond, and the second is pi bond is formed in addition to sigma bond. So pi bond is observed in case of multiple bonds. So pi bond is a weaker bond. Now next, let's see the differences between sigma and pi bond, or if you are asked a question, distinguish between sigma and pi bond, you can write these differences. Sigma bond and pi bond. The first difference is sigma bond. It's formed by the overlapping of orbitals along the internuclear axis. Pi bond, it's formed by the overlapping of orbitals perpendicular to the internuclear axis. Now the second is sigma bond is formed by the overlapping of SS, sp and pp orbitals, whereas pi bond is formed by the overlapping of only p orbitals. Now sigma bond is a strong bond, pi bond is a weak bond. Now sigma bond, free rotation is possible, means it's a sigma, single bond, means we can rotate that bond very easily, whereas under pi bond the free rotation is not possible because pi bond we observe in multiple double or triple bonds. So it's very difficult to rotate that pi bond. Now sigma bond has only one electron cloud, whereas pi bond has two electron cloud above and below the atomic nuclei. So these are the differences between sigma and pi bond. Now we have a last question here. Why helium molecule is not formed? Helium molecule. Whenever you write helium molecule, you write the symbol as He and not He2. Or you can say why helium exists as a monoatomic gas. Or why He molecule is not formed. The answer is, you know, helium. What is the electronic configuration of helium? 1s2. It has completely filled 1s orbital, and so these orbitals cannot overlap. So helium molecule does not exist. Helium always exists as a monoatomic gas. Okay, so this is valence bond theory, under which we saw the orbital overlap concept and also about the two types of covalent bond, sigma bond and pi bond. And sigma bond is stronger than pi bond, and the differences between sigma and pi bond. Thank you.